A test plan sets out, in advance, what you will test, what data you will use, and what you expect to happen. That phrase, in advance, is doing the work. Deciding the expected result before you run the test is what turns it into a test at all. Otherwise, you run the program, see what it does, and unconsciously accept that as correct. A test plan usually has 4 columns: the test data, its type, the reason for including it, and the expected result. And notice what is missing from that list: the actual result. You fill that in afterwards, and a test passes only when the actual result matches what you already wrote down. 4 types of test data, and each exists to prove something different. Normal data, values that are valid and typical, which the program should accept and process. These show that it works under ordinary conditions. Abnormal data, sometimes called erroneous data, values the program should reject, such as text where a number is required or a mark of 150. These prove the validation actually rejects things rather than merely being present. Extreme data, values at the very ends of the valid range, which should be accepted, for a mark out of 100, that is 0 and 100 themselves. And boundary data, pairs of values either side of a limit, one accepted and one rejected, for that same range, that is 0 and -1 at the bottom, and 100 and 101 at the top. The distinction between extreme and boundary is the one students find fiddly, so hold it this way. Extreme data is the largest and smallest values that are still valid, one value each end. Boundary data is a pair straddling the limit, one valid, one not, testing that the line is drawn in exactly the right place. Boundary data deserves its own explanation because it is the category that actually finds faults, and it is the one most often left out. Nearly every off-by-1 error lives exactly at a boundary. Suppose a library allows borrowing from age 12 upwards, and the programmer wrote greater than 12 where they meant greater than or equal to 12. Test with age 20, works. Test with age 5, correctly refused. Test with age 100, works. Every one of those passes, and the bug is still there. Now test the boundary pair. 11 should be refused and 12 should be accepted. 11 is refused, correct. 12 is refused, wrong. The fault is found immediately, and only that pair could have found it. That is the argument for boundary testing in one example. Normal data tests what you expected to happen, and boundary data tests whether you drew the line in the right place. So work the library example through as a plan. The rule: members must be 12 or over. Normal data 20, valid and typical, expected result accepted. Abnormal data, the word 12 typed as letters, the wrong data type, expected result rejected with an error message. More abnormal data, -5, impossible as an age, expected result rejected. Extreme data, 12, the smallest valid value, expected result accepted. And boundary data, the pair 11 and 12, 11 expected to be rejected, 12 expected to be accepted. Notice that 12 appears twice as extreme data and as half of the boundary pair, and that is fine. The same value can serve 2 purposes, and it is doing different work in each. Notice too that every row states the expected result. A plan without expected results is a list of things to type, not a test plan. Choosing test data well is a judgment, and there are a few habits worth having. Cover every rule in the specification, not just the interesting one. A program with 3 validation rules needs test data for all 3. Include at least one value for each of the 4 types, because a question asking for a test plan generally expects the range of types rather than 5 normal values. Choose values that are easy to check by hand so you can tell whether the output is right without needing a calculator. And test the paths through the program as well as the data going in. If there is an IF with 2 branches, some test data must take each branch, or half the program has never run. That last point is the one people miss. Data that never triggers a branch has not tested that branch, however valid it is. Take the second worked example, a discount rule, 10% off orders over £50. First, notice the ambiguity. over 50. Does an order of exactly 50 get the discount? The word over says no, so the boundary sits between 50 and 50.01. That is worth spotting because a large proportion of real bugs are ambiguity in the specification rather than errors in the code. And the moment you write the test data, you are forced to decide. Normal data, £75. Expected result, £7.50 discount. Normal data below the threshold, £20. Expected result, no discount. Boundary, £50 exactly. Expected result, no discount, because the rule says over. Boundary, £50 and 1 penny. Expected result, a discount. Abnormal, minus £10. Expected result rejected. And extreme, £0. Expected result, no discount and no error. Look at what that pair of boundary values does. It pins down exactly where the rule changes, which is the only place a comparison operator error can hide. One honest point that questions sometimes ask about. Testing can show that a program has faults. It cannot prove it has none. Except in the simplest cases, you cannot try every possible input. So passing every test in your plan means the program works for the cases you thought of, which is exactly why the types matter. Normal, abnormal, extreme, and boundary are a structured way of thinking of the cases that catch the most faults for the least effort, rather than a ritual. It is also why testing continues after release, and why the maintenance stage of the development life cycle exists at all. Users find the cases the test plan did not. 4 things to take into the exam. First, name the 4 types precisely and know what each proves. Normal is accepted. Abnormal is rejected. Extreme is the valid limits accepted. Boundary is a pair straddling the limit. Second, when asked for test data, give actual values, not descriptions. A number that is too large is not test data. 150 is. Third, always state the expected result alongside the value, because a test datum without an expected outcome cannot pass or fail. And fourth, keep extreme and boundary apart. Extreme is the largest and smallest valid values. Boundary is a pair either side of the limit. That last distinction is the one most often lost, and boundary data is the category that actually finds the bug.